me introduce the next speaker. We have Hans Miller, who's the Chief Engineer for Research and Advanced Capabilities Department at the MITRE Corporation. So he's retired with over 25 years of experience in the Air Force, with his last assignment being the Division Chief of the Policy Programs and Resources Division at Headquarters Air Force Test and Evaluation Director at the Pentagon. Prior to that assignment, he was commander of the 96th Test Group at Holloman Air Force Base, New Mexico. He is a pilot with over 2,100 hours and 35 different aircraft types. Commissioned as a graduate from the U.S. Air Force Academy. He holds a bachelor's degree in Aeronautical Engineering and master's degree in Aeronautical and Astronautical Engineering from Stanford University. Thank you.
Of course. All right. I'm going to use this mic because I'm vertically challenged, so standing behind podiums is just not my thing. So if I could bring up the second slide, I'm going to just, this brief has two parts. One is talking about a National Academy Sciences study. I was part of a committee that was commissioned by DOT&E. And the second part is kind of some slides I put together to say, oh, how do we think about this in relation to how we are thinking about T&E? So the thought exercise I want to have is when we have models or frameworks to think about some things, they're hard to let go of, especially if we've had them for a long time. I was listening to a book on tape called A Short History of Nearly Everything by Bill Bryson. If you haven't heard it, it's a great book. And one of the models he talked about was the baked apple model of explaining how mountains were made, right? And this model, this framework for thinking about the Earth was around for decades. And the theory of plate tectonics came up, and it took 100 years before it was accepted, even though there's a wide variety of evidence to say the baked apple is wrong. So I'm not saying this is wrong, but I'm saying we need to rethink this framework. How many people saw this in TE 101? TE 101, how many saw the wedge? Have you, anybody familiar with this? No? Nobody's seen this before? This wedge model of thinking? Okay, so I'm surprised. I thought this was pretty ubiquitous. But this has been a very classic way of thinking about T&E, progressing from modeling and simulation to installed system testing to open air systems. And what I'm going to talk about and what you've heard already, there are things about the environment, there's things about the nature of what we're testing, there's things about the tools we have that really challenge this framework when we think about these efforts at T&E. And so I'm going to present that at the end, but I'm just going to give you a thought exercise, showing this now, chew on that as we think about the things you've heard and what I'm going to talk about, and how might we look at that differently. I'll throw out my thoughts on it, but I'm very open to hearing about things as kind of a crowdsourcing. So if we go, next slide. So the opening statement we had from Mr. Beeler, the former director of DOT&E who commissioned National Academy of Sciences, was this quote, and it was echoed in former Secretary of Defense General Mattis, but it's basically, this essence is the same. The technology is, our adversaries will have the same technologies. There's probably not going to be a country that's going to have a monopoly on a technology that's going to be a game changer that only that country has. The question is, how do we effectively integrate it into combined arms that's going to make the difference on whether we succeed in operations? So how do we understand that is kind of a core background thought and entering comments. So this quote stuck with me the whole time we were doing this study. So if we go to the next slide. So I presented this to a multi-domain at ITEA, and when we first started talking about T&E of multi-domain, I had several people come and say, look, we've been doing this for decades. It was interoperability testing. And I would argue, no, this is different. Interoperability testing is system-focused, system-centric. How does my system interface with this system? Does it interoperate? When we talk about multi-domain and how we look effectively combined arms, it's different. So let's go ahead and build up this slide. So yeah, system to system, that's interoperability. If we build it up to the right, and that's what this wedge was based on, right? And then it's also based on our classic 5002. If we go to the right, go ahead and build that slide up. Now we look at multi-domain, we're talking about the idea of multiple systems across multiple domains, providing data that somehow gets fused together, somehow gets put to a decision engine, and somehow then gets out to shooters to most effectively use those. So this is really about how are we tracking data? How is data captured? How is that fused? How is that managed? How is that distributed? Those are the questions that really are the questions when we think about the T&E of this environment. Oh, and by the way, how from an operational test, from a survivability perspective, do we represent going to build it? Red's ability to do the same thing, right? If you go build the slide. So what does that model look like, and how do we represent the red version of that? All right, so another thing to kind of think about, but I think it's really important to understand that distinction between interoperability and when we think about multi-domain. Next slide. Okay, so this was what we were asked to do. When we think about the range of the future, what is this physical and technical suitability? Mr. Beeler's point was the ranges, many of the ranges we have today were built on the Cold War and many of the systems. And we also had an approach to testing where it was, I am testing this system to get through its different milestones to make a production recommendation and move forward. And we really, when we think about testing as we're fighting where we need to, that framework does not necessarily support where we need to go. So that our study was to look at that. Next slide. So what are our main themes? We talked about joint all-domain operations. I think multi-domain. I know different terminologies have different contexts depending on where they came from, but fundamentally it's the idea of all-domain systems working together. Digital technologies. Foundationally, we have seen obviously many changes in digital technologies, application of digital technologies that are advancing quickly. How do we incorporate those into our processes? And obviously, there's that need of speed to field. So time to field is a risk inherent in itself. So when we talk about testers, a test community, really, we are risk mitigators. You're not going to 100% test the system, but I think we had that in the AI discussion. How do we quantify the risk of what we are and are not looking at? And what is good enough for the system balanced against the need to get things out and integrated into the field? Next slide. So we looked at a lot of challenges, and an interesting one that came up, and I won't go into it hugely, but there's a real fiscal challenge and policy challenge because we are inherently in the DoD program focused, program centric. Everything comes from funding to a program. The hard problem is how these things integrate. So who is the champion for that? And I think DOT&E is trying to take a lead role in saying, hey, we need to look at that, but who is funding that? Who is the champion for that? When I go to TRMC and say, we really need these things, well, who's the program that's going to be funding that testing? So there are some challenges there in terms of how we're set up. Next slide. That also is a challenge for T&E as a continuum because who's funding? There's a different funding model when we look at that versus how we're funded now when we think about the funding of a test program or test strategy. So it's you're looking at building up those complex environments and how do we represent those, and looking at new operating systems. How do we think about test DevOps and enabling that both from the structure of our test organizations as well as the tools we're using. And then I talked about the funding model. Next slide. Okay, so when we look at where we are and where we need to go, there's a scaling factor in this complexity, right, that's happening. So there's been clear component testing, platform testing, but we're into this complex system of systems with integration of advanced capabilities. The likes have just accelerated significantly. And to both previous briefs and other briefs you've heard, we cannot do this with our current just hardware in loop and live testing models. There needs to be a aggressive implementation, but I would argue also tight integration of these tools, as well as how we do data sharing and data repositories. We can't just be stovepiped by our systems. Next slide. So when we look at that notional concept for the range in the future, you've heard these capabilities, but when we look at that DoD data, it's really about understanding those architectures in terms of not only how are we capturing the data, but how are we looking at how that data is taken and then into a usable mechanism such that we can actually retrieve it and use it for other systems. What are our standards? What APIs are we setting for our model repositories? It's great to see these pictures of digital engineering and how we're using the digital twin, but what are the architectures and the contracting mechanisms to actually allow that to happen? Because the actual implementation of that is very difficult without some concurrent changes. Range connectivity sounds easy. Very, very difficult. We have really hard policy challenges just on how do we share data across the ranges. Right now, it's very difficult. It took a long time just for Nellis to talk to Edwards when we got to secure data because there are different authorities to operate in each of the services. You still have to preserve hardware in the loop, so you still have to do specific testing for like hypersonics. You have to invest in those things, but you need to look at how they're connected. And then how do we do your test DevOps? And that gets more to the T&E as a continuum in terms of how we continue to look at and how can we update the environment. So we think about one of the challenges of the current paradigm. Sometimes we've seen modeling and simulation community and the T&E community. And I think the reality is, when we're talking to in other themes, is you see that we can't think of it that way. The modeling and simulation tester, physical tester, they're virtual and physical testing, but all within part of the same community. If it's something that's sought separately, it's not effective. Next slide. So that's obviously an area to emphasize. Next slide. So as we look at that paradigm and the structure of the testing, we're looking at these M&S models that are really connected. And I'll just read some quotes from our paper here that I thought was good. So component and subsystem models are not necessarily reused in system models, but their data and results enable the development of more abstract models suitable for system validation. Modeling and simulation is not simply used to predict test results, which is, I think, the historical model, but it is used to focus testing in particular areas with a goal of driving down uncertainties in system level understanding. So it's kind of thinking differently about how we are using models. It's not just predict, test, validate. It is how are we thinking and changing that in terms of, if we're relying a lot on these modeling environments, how should we thinking about our live testing such that we can buy down uncertainty and reduce the uncertainty of our models? And then that gets to really carefully about what are our data strategies for when we do capture things from the field, creating our data strategy based on the consumers of the data, not having that be an afterthought. Next slide. Okay, next slide. Okay, so, we need to test as we fight by representing these multi-domain and the data flows associated with it. Next slide. We talked about, and there's been some issue in terms of what you want to call this and where it lives. There can be many instantiations, but the intent here is there needs to be a mechanism by which we can focus on the testing and the validation of where systems contribute to and how they integrate into the fight. Next slide. So it is time to evolve that understanding. So, and the reason for that is, if you look at this, these are all really good components of T&E. I'm not arguing that we get rid of these components, but what we are saying is that this model implies a progression from modeling and simulation to hardware in loop to open system testing, with this being the graduation, where maybe that's not that way anymore, and that there's much more of this cyclical nature of the testing. The components are still there, but it needs to be it needs to be evolved and different. Next slide. And this is also, and I pulled these slides from a DAU course that I took. It was a level 1 T&E course And this was from 2 years ago, so I'm not sure if it's changed now. But this was taught as a predict, test, validate, which is not wrong, but there's different additional things we should be thinking about when we think about modeling and simulation and how we use models and tools. And I'll show those in a second. Next slide. So it's not wrong, but doesn't fully exploit it. When I was in the Pentagon, we were talking about joint simulation environment. So I was working some of the initial requirements for that. And some people are saying, well, great, now we have the JSE, we don't have to do as much live testing. And it was presented as an either or. Either I'm doing simulation, virtual testing, or I'm doing live testing. And that is not the way to think about it. The way to think about it is, how do we use these two together to complement each other? Using and growing our virtual environments does not mean we don't need and shouldn't leverage our capabilities in live range. The question is, what is the nature of those tests we do in the live range? What is the purpose of those tests we do in the live range? And should we be thinking more about that live testing being used to help reduce uncertainty of the models in those edge cases to better understand them versus reinforcing what we have high confidence in from a model? So it's a complementary. And the other reason it's complementary, if you go to the next slide, is, and this was alluded to in Dr. Warner's brief, but if, that trapezoidal shape for people who've been at the Nellis range, it may look familiar. We have a lot of threats there. I put the threats on the other side. But the idea is, we can represent a push and we can represent a fight against some threats, but we have distances of threats, distances of sensors that we just cannot fully represent. And we are trying to connect some live ranges to try to get that in our live ranges, but those are going to be pretty few and far between when we can do those full up, and we need to do multiple iterations. The other big thing is that the idea of having transit windows of satellites where you can do things unobserved is gone, right? Any war reserve modes, they're going to have to be in some closed environment. And then, more importantly, when we look at the way we fight or the need about integrated arms, going back to Mr. Beeler's comment, is how do we effectively show the combination of, it's not going to be a cyber attack and a kinetic attack and a directed energy attack, but how do I use those in concert to most effectively achieve the effect we're looking for? And you really need some virtual representations to be able to effectively do that. All right, next slide. So the changing system under test. There's two parts of this that are changing, right? We saw that the Agile Acquisition Framework has opened up now. There are 6 5000 series dealing with different approaches. So 5000.87 now is, as you referenced in your brief, an iterative process. It is a very different acquisition model to our legacy milestone. And it's not that 5002 is wrong for certain situations. There may be certain MDAPs where that model absolutely just still applies. But the wedge that was associated with that is not necessarily how we should think about T&E for what's on the right-hand side. The other thing to think about is that when we look at, let's say, I worked with the Skyborg program for a little bit, and you look at an autonomous system, and if we can truly realize this rapid evolution of software from being able to release capability to the field quickly, when are we going to actually get able to operationally test that? And will we always be able to bring a system back to a range to get operational data, or is the majority of data we're going to get from the operational environment itself? So as we think about this testing, how do we actually get data that's coming out in the field back to our environment? And this happened with the F-35. They did a month of testing on Nellis. And then they also, the aircraft itself is huge. The production data aircraft collects a huge amount of data that hadn't previously been fully exploited. A week of testing or a week of data collection from an operational unit at Hill produced more data for operational T&E and analysts than the month that they had at NITRE. And so we need to be thinking, and so the 53rd Wing for those who are, there's some AFTEC folks here. So the 53rd Wing, if you know them, their Tetraraptor is looking at, and Kevin Burns is his name, but I talked to him and his data strategist. They're looking at how to get data from the F-35s that are deployed to the operational environments back for their OT testing. That needs to be the vision for the future. So when we think about continuous T&E, it includes the idea of being able to data capture from the field and bringing that back for analysis, and then sending that back for your future updates. Especially true for autonomous platforms, you know, where I'm bringing that data back to the field. How do I look at how I'm training the future systems? Am I allowing it to just adapt based on what it sees, which opens up a whole ton of vulnerabilities? Or do I bring that data back, do some analysis, and say, okay, this is a good set of training data for the next round? Next slide. You've heard about the digital thread and digital twin. I think the key thing here is how do we take the data we're getting from our T&E campaigns and feeding that back into the data model? So, you know, the concern I have is that there's a contract for a vendor to build a digital twin, and that vendor's model is no way connected to the data we're collecting on the range. And so how do I maintain the most up-to-date virtual twin that must be, because that's going to, unless we have a regular update cycle, that virtual twin, that digital twin is going to atrophy pretty quickly. So there's a huge sustainment cost in maintaining an effective digital twin. Next slide. So when we talk about continuous test and evaluation, you know, there's a historic model here of you have your government test, your contractor DTD and government DT&E, and your government OT&E, and the data that is collected in each of those. I think we've gotten better at some of the data, but there are situations where some of the OT tests, because we couldn't get the data from the contractor, we had to repeat the same test, which was you know, really difficult to take from a time and cost perspective. So when we think about this, we're really in this idea of, you know, the design, test, build. If you're thinking about that more agile cycle, and you're looking at maybe automated test scripts, if you're looking at a software factory, then what is the role of our T&E organizations? And I would argue our role there is there's still an active role for DT and OT equities, but that really comes into how are we informing those user scripts? You know, if they're just done and the test scripts are only done by the vendor with no DT and OT involvement, that can go sideways pretty quickly. Next slide. So we think about the relationship of the virtual and the physical. You know, I would argue this, you know, this is more the way I think we're thinking about it, or should be thinking about it, where those virtual models are really helping us understand where the key areas of uncertainty are. And those areas of largest uncertainty, that's where we focus our live testing. And then we also look at, that informs our data test and data strategies. Next slide. So how do we think about evolving this model? So I'm going to throw out some thoughts here, and again, happy to take comments. So go build the slide. So, you know, you have your physical world that you're operating in. Next slide. And then you have some modeling in virtual environments. You're not going to be able to create everything in the physical world, but you try to represent in different instantiations at different levels. And then you have ground test to include hardware in the loop, installed system testing facilities, and those have, you know, anchored in some hardware in the loop, so you have some actual physical things, but you probably have some virtual environments like scene generation or other things. And then you have your open air ranges, and your open air ranges obviously are in the physical world, but we're bounded on those open air ranges and the distances and what we can represent on the range. And you have the other part that I would include here that's not in the current wedge is how are we getting data from the mission environment? How is that feeding in? And then that orange loop is that idea of that continuous cycle, that data flow is going across, and we're feeding information from the ground test to our physical open air range test, to our modeling and virtual environments. All that data is feeding together. So at the middle, you really need to have those model and data repositories. Okay, next slide. And I think that's it. So I would argue that that's kind of how we think about when we go forward and how we apply some of the findings from our briefing. So I think with that, I'll end there.
Thank you. Does anyone have any questions? Well, I'll start with one. So you mentioned the funding for this joint multi-domain testing. You know, individual program offices don't budget for that. So do you have a recommendation on how we could do that as a department?
Yeah, so we talked to DOT&E when we gave the outbrief, and one of the things was, you know, is there either an expansion of or a way of thinking about joint test and evaluation where we both go from just ConOps testing to more of that mission testing and helping to inform that. For those who are aware, there's a thing called Orange Flag and Emerald Flag where they're trying to do that multi-domain testing, and it's excellent work by a lot of really motivated, and it came out of younger officers. The challenge there is that it's based on what the programs want to do. So it's kind of a, what does everybody want to do? We take that all together, and that informs the objectives. So the instructors are driven by the programs, and I think you can still maintain that model, but you need that office that can say, oh, and by the way, here's the COCOM level objective, and here's some funding that we can add into it. So it's not exclusively, I don't think it needs to be this giant burdensome organization, but there should be some mechanism that that organization can fund those. So that was our suggestion, is that it'd probably be good that that came under the broader DOT&E umbrella, but there's that funding, so it's an expansion of what we do in JT&E. You could maybe look at that way from a funding model, and those are discussions. But I think at the end of the day, what we came out of it though is, if that's really the key, if that is what we're saying is the key to winning the next fight, then we have to put some skin in the game in terms of how we do that.
Any other questions from the audience? No? Okay, well, thank you very much.
Thank you.